Welcome to the TRXL podcast. This is Evan TRXL. If I sound a little different, maybe like I'm coming to you from a different location, that's because I am. TRXL HQ has a new home. I've officially landed in the Pacific Northwest. More specifically, I'm now officially an Oregonian. So after a short hiatus, I'm thrilled that the podcast is back. If you've been a longtime listener, hopefully you know by now, my goal with this podcast is to add value to the people of the AEC industry, that's you, through these conversations. And I couldn't be more excited about the upcoming guests on the show as we track the coevolution of architecture and technology. If you're new to the podcast, welcome. I recommend going back to the beginning of the catalog if you're looking for a master's degree level of education in this realm, which is all made possible by the incredible guests that have joined the podcast over the past 2 years. Before we get into today's conversation, I want to let you know that I've been working on many things behind the scenes to get ready for what's next with TRXL, and I want to tell you about them now. I've got a new website, which is allowing me to do some great new things. The address is the same at TRXL.co. The first new thing this allows me to do is have a newsletter. I'm now publishing a TRXL AEC Tech email newsletter about once a week, and at this point I've already published 5 of them to help you track the pulse of our industry. So why do a newsletter? It's a way for me to share more granular industry news that adds to the context of the podcast episodes. My goal is for the episodes to be more of a timeless resource, so naturally the topics aren't about the latest news. And the newsletter helps fill out the spectrum of AEC and tech on TRXL from my perspective. Check it out. I think you'll like it. It's your very own shortcut to the things worth paying attention to as we track the coevolution of architecture and technology. So far, my readers have told me it's a great format, an editorial lens, and one reader said she feels like she should pay me for this, which is a nice segue to my next topic. So next up is sponsorships. TRXL is once again an independent podcast. I've built a small team to produce the show, and with the changes to the business, I have to find ways to make it work. Ad-based sponsorships, which you're already familiar with on the show, are something I'm now solely responsible for here. So if you're a brand or company who has a product or service worth putting in front of this lovely, loyal, and dedicated audience of AEC industry professionals, I invite you to get in touch with me by visiting the sponsor page on trxl.co/sponsor. But that's only a part of how I'm approaching making this work. The next thing is what I'm really excited about: memberships to what I call TRXL Plus. I now have the technology in place to invite you to directly support what I'm doing here. And by offering memberships, it's my hope that you see the value of this endeavor and that you will directly support what I'm doing here. When you become a member, you'll receive some nice perks, and the biggest benefit is that member-supported content is ad-free. I think this makes the most sense for those willing to directly support what I'm doing here. So with membership to TRXL Plus, you'll get your own private feed for ad-free episodes of the podcast and an ad-free version of the newsletter with additional member-only content over time. And I'm doing a special launch offer for the next month that's for you early adopters out there. It's a pretty nice discount that is applied for the first payment for yearly supporters. A link for the special offer is in the show notes for this episode and on the website, so it shouldn't be too hard to find. My goal is for the TRXL podcast and newsletter to add value not only to our industry, but also to you and your career. And I hope in return you can help me do that and more by becoming a member. So in summary, we've got a new season of episodes with an amazing lineup of guests coming, the new TRXL AEC Tech newsletter, subscriptions and memberships with a special launch offer for the next month for you early adopters out there. And you can see all of this and learn more at the fantastic new TRXL.co website. That's TRXL.co. There's also an announcement outlining all of the things I just talked about on the new site, and you can find a link to it in the show notes or at TRXL.co. Okay, with that, let's get on with this episode. In this episode, I welcome Roger Krulak. Roger has over 35 years of bringing innovation to the construction and development sides of the real estate business. In 2016, he founded FullStack Modular, which has established itself as a disruptor using advanced technologies for building design and using high-rise modular construction. Tech-driven and made in the USA, FullStack has factories in Brooklyn and Portland, and it specializes in mid- and high-rise multifamily buildings, hotels, and student housing in urban environments. Roger received the Popular Mechanics Breakthrough Award in 2014 for his work on creating a high-rise modular process. He also sat on the International Panel of Experts for Singapore from 2014 to 2016. He frequently speaks at the country's top design schools and universities, including MIT, Harvard, and Yale, and he's been publicly recognized as a leader in innovation with multiple features in the New York Times, Wall Street Journal, Wired, and many others. Roger received his degree in management and organizational psychology from Babson College. In this episode, we discuss FullStack's design to manufacturing approach, how they achieve their deliverables using parametric design tools, the typical inefficiency of development that drives innovation at FullStack, the degree to which the building industry is, in Roger's words, a big monster, design for manufacture and assembly, or DfMA, the goal of getting the entire team all on the same side of the table, industrialized construction, and other topics. So without further ado, I bring you my conversation with Roger Krulak. Roger, thanks for joining me today.
Evan, thanks for inviting me to visit your show.
Yeah, I'm looking forward to this conversation. I've had a couple of guests on here before talking about modularized and prefab, things like that, and you're a veteran in this space. And so I'd love it if you could maybe start at the beginning of where did this idea come from? How did you get here? What has your trajectory been in the industry to get to this?
Certainly, one way to describe it is that there's really nothing new under the sun. And to be fair, I grew up in a construction and development industry and family. Always were working on housing projects, even from a very young age. And my grandfather was involved in a modular company in the early 70s as part of Project Breakthrough. I don't consider myself that inventive. However, while I was working for Force City and we had the charge of building 6,500 affordable housing units, I was lucky enough to develop a solution to build high-rise, dense urban environment modular buildings, a significant height, which was, in my mind, the breakthrough that has the value.
Okay, that is a lot of housing, 6,500 units. And was that over a long period of time? Was that in a short period of time? Was that one project? Like, how did that's a big number.
It didn't actually all get built, but the reason we created the system was to build it. And then, of course, one of my favorite quotes, life is what happens when you're making other plans. The economy was tight. A bunch of the land got sold to a Chinese development company. And so we built the tallest modular building in the world, which is no longer the tallest modular building in the world. But the system got proven out, and FullStack Modular has been able to take that and utilize it across the country.
That's interesting. So it's in the name, right? It's this idea of going up with modular and stacking these blocks on top of each other, like building Legos. Like you said, your grandfather had a history in this. It's in your blood, maybe in your DNA. Tell us that story of like, how did you get from not building like this to actually like developing that system to build like this?
Yeah. I grew up in what you would call the Midwest, which isn't really the Midwest. I grew up in Cleveland, Ohio, and we were very used to building buildings on a very tight margin with very predictable costs. And when I moved to New York, not only did my head spin, I couldn't believe the amount that people were working, but it was incredibly interesting and distressing at how volatile the construction market was for anything of significant size. And Force City, the company that I was working for, had made this commitment to build all these affordable units. And from a business perspective, it just made no sense. It didn't feel like you could ever make those kinds of amount of units with that density, given the construction environment, happen. So when something isn't working, you can either throw up your hands or you can come up with another solution. And I was fortunate enough to be able to be given a little R&D money and create a world-class team to try to come up with a solution to predictably deliver cost-effective mid to high-rise housing in a factory. And that's where FullStack Modular really started.
That's interesting. So just the ability to make the decision to try something completely different, did that get birthed inside of Force Cities?
Yes.
Okay. That's a huge risk.
It was a huge risk. And I remember even today the investment committee conversations about should we try this. To the credit of the former executives of Force City, they decided that it was worth it. And I believe that it was the next big step for the modular and certainly fully volumetric modular industry to allow it to move forward where you see the kind of growth that you're seeing quarterly.
Yeah, I want to pause on that for a moment because I think that's kind of rare, and at least in the architecture space, for a company to take time out to explore a completely different business model. And I can only imagine it's not only risk from the standpoint of you're doing it differently, delivering in a much different way, but all of the infrastructure it takes to put in place to actually make that happen, to build the machine, basically, to produce and take total control over that entire aspect. Because when you're going into this, it's a paradigm shift compared to the type of way you're used to delivering buildings. You're now responsible for every single piece of it. And I guess as a developer, you kind of are, but it doesn't mean you do it all, right? You maybe orchestrate and do those things in the background, kind of like an architect would do with a building, right? They draw the plans and then they observe, they do construction administration. They're not actually doing that kind of stuff. And so to do this kind of business model shift and actually take charge of all of that had to be like, I'm just wondering, like, what were those kinds of conversations like for the business to say, we're willing to explore that?
Well, first of all, great question. And I think you far underestimate the amount of effort that takes, because it's not only, yes, we're taking all of this under our own wing. It's we're going to change the trajectory of design, bid, build process that is 13.5% of the world economy. And we're going to tell everyone that they should follow a design build approach or a design manufacture approach, because that's the only way you could really build modular buildings.
Yeah.
That's on one side. And on the other side, anybody who's been in the architecture or engineering industry for a long time knows that over the past several decades, if not several score, the movement away from collaborating on decisions in a way that is effective and coming up with complete executable designs has been going the opposite direction, partially because of the insurance industry, partially because of the insurance for the professionals involved. And so not only do you have this sort of iterative value engineering process, you also have a hands-off approach by force for two reasons. One of them is the developer doesn't want to pay the upfront costs that it really takes to do a comprehensive design engineered. And two is that the insurance companies don't want the architects to tell the mechanical engineer that that system's not going to fit. So in some ways, I agree with you. It is a lot to take on. On the other hand, I didn't really see the way that the industry was moving, that there was any other way to get anything done before I had to retire. So.
Yeah. So you had to do this.
I do feel like maybe, I don't know if I had to do it, although I'm definitely someone who likes to shake things up if they're not working. But I do think the industry needs this as a tool. A shift in the industry must be design build for anything that is parametrically achievable. And multifamily buildings have so many fixed parameters, you're not asking for a lot. Whereas, museums or bases or new city developments, there's not that many parameters. You have a lot of flexibility. But if you're building a mid to high-rise building, you need elevators and hallways and stairwells and windows in the bedrooms for the most part. And you don't have that many decisions to make. We add a few, and it ends up being a little bit more controlled process. But at the end of the day, the one thing we do is we design for manufacture. We make it so that you can build it in a factory and stack it up like Legos, as you described. And the only way that happens is if everything is built to the exact precision that it needs to be in order to be able to put it together.
Yeah. I can only imagine the huge shift that had to happen as you went through this process for the development company, not only from what you're delivering, but also how you're delivering it, how the team produced the things, the learning that had to happen to produce for manufacturing, to draw for that or to model for that. And so maybe take us through some of that process that happened, because this is a major evolution for a business to go through. And I think on many levels, people think they have to start over or start fresh rather than try to change the thing that already exists into something else.
Well, actually, I think it's an interesting question, and I'm not sure if I'm going to answer it directly, because I look at it this way. I look at it as the inefficiency of development from the world we play in, which is housing of any sort, hotels, student housing, affordable housing, market rate. The deficit in all of those markets is relatively insurmountable. And the production of housing units worldwide in the United States, pick a state, is well below the need. So it's really hard to imagine that we as human beings and innovative people and in a very wealthy part of the world can't solve a problem. And we have created, I hate to say it, a big monster. I mean, the industry is slow and inefficient across the board. And so that frustrates me to no end. And one option is to quit and become a cook. And the other is to try to shift the way that we do things. And yes, it is a colossal effort. It requires exactly the opposite of the process that we as an industry are used to. And it also requires a shift in attitude for all of the players. I mean, a design build team is all of the stakeholders sitting on the same side of the table trying to figure out how to accomplish goals. That is not how we as an industry have been behaving for, I don't know whether it's 50 years or 100 years or 400 years, but it's for a long time.
And how long has 4Point been in business previous to this?
FourCity been in business for 100 years.
Wow.
100 plus years. Yeah. And to be fair to them, the modular business that I mentioned was actually originally part of FourCity in the 70s. Okay. And it failed because they had one customer, which was the U.S. government. And once that project breakthrough, which was affordable assisted living facilities, once that program dried up after the end of the Carter administration, that business dried up.
Okay.
And that was showing my age a little bit, but I was a young kid when that happened. So I remember it very distinctly. And it was a concrete solution, and it was amazingly efficient for what it was, but amazingly inefficient for what it is that we're talking about right now.
Yeah. So take us through kind of how tech plays into this, because I think you said that it started around the 2008 recession time. And obviously there's been a huge shift in the last 15 years over in the technology space, and things are moving quickly. But give us an idea of how that started and how it's going now, because I can imagine there's been huge developments in that realm.
Oh, yeah. It's interesting because I mentioned that this early 1970s modular was literally people drawing on blue line paper, trying to create a way to manufacture things in an intelligent way when you really couldn't. There was no parametric design. There was no CAD really to speak of. So in 2008, it was way farther along than that, but it was still pretty early on in the evolution of AI tools, parametric generative tools, and all of the things that are now rolling out on a daily basis. But the three-dimensional CAD drafting, whether that be in a CATIA framework or a Revit framework, it existed in 2008 and has always been necessary, because unlike a building where you have specifications that say mechanical ducting has to be at this tolerance and steel has to be at this tolerance and wood has to be at this tolerance and plumbing pipes have to be at this tolerance. If you think about building in pieces, everything has to meet the same tolerances.
Right.
So the drawings had to be precise, right? And the integration and clash detection and all of the things that we talk about are matter of course for building offsite and having the tools to measure that accurately, which was a huge challenge in 2008. And basically you can buy on Amazon something that measures to that accuracy if you know how to use it today. So so technology is making this process significantly easier, and the risk factors significantly less, as long as you're considering the right parameters.
I want to go back to something you mentioned a minute ago about the inefficiencies of traditional construction that you've lived through and grown up with versus what you're experiencing now with this that you can't achieve without technology and without all the players at the table, without them all sitting on the same side of the table. If you were to throw a number out, what would you say is the waste in that process if you were to think about it from like dollar signs, right? Is it 50 cents on the dollar versus something way less in this direct to manufacturer type? Like what? Yeah. There is so much at so many levels. If you were to just kind of take a swing at that, what do you think that number is that everybody who's dealing in the old paradigm still at some level is just accepted? They've just accepted it.
That's such an interesting question. And one day maybe I'll have the money to pay somebody to figure it out. But I think these are the things you have to think about what they cost. For instance, how much does time cost? It obviously costs a lot more now than it did 7 months ago. How much does, when we were at Forest City, we did a lot of residential hunting. Like how much does a development process where you're kicking the tires and all of the people you're paying to do that, and the architects and the engineers and the lawyers for projects that never happen? How often does that happen? How often does somebody have a development idea and then they go send it out to a general contractor, the price comes out double what they can actually afford to make the pro forma work in? And then how much does it cost when you buy out a project, you sign a contract where you're not on the same side of the table and the general contractor or the architect use the holes in the project to get change orders and increase costs? So what do really contracted projects, how much do they really cost at the end of the day? How late are they? How much does that cost? So you're asking a question that I'm trying to put all the pieces together. And my guess is you're probably, if you were able to calculate it, fully in the 30% range of wasted money. Now, of course, it diminishes if you're doing multiple projects. In both cases, if you're doing multiple projects that are somewhat similar, and obviously geography by geography, the dollar shifts. But I would not be surprised if that's not a 30% waste number.
I wouldn't be surprised if it was higher than that. I've heard it as high as 50 cents on the dollar. And like that's a big dirty secret to people who buy buildings, owners who do the development. And it's because that's an enormous amount of waste in the process. And that speaks to these types of solutions that you're talking about with owning this whole stack all the way through and the amount of efficiency that you can gain by doing it. And you said it's not for everything, right? It's not the solution for all buildings everywhere, but it does fit quite a few different verticals. And it seems like, I'm just wondering, did you guys think about that when you were first starting out with this idea about that? The sheer amount of waste that could be avoided, or at least that you could get a lot better at over time?
Yes. The interesting thing about it is that a factory or a productization, regardless of what it is, whether it be housing or cars or telephones or earth movers, the value proposition is the more that you manufacture something, the more you get efficient in it. If you think about the actual construction, the hard costs, as it were, you have labor and materials. Can you actually buy materials better if you're manufacturing them? Maybe a little bit. But what the real opportunity is labor savings, right? And labor savings happen on logical repetition to meet the market need of what's going on. And so the value proposition is so antithetical to the way that we do development today. That requires a mind shift. And there are people that are getting it now, but when we started in 2008, every meeting I went into, somebody under their breath was talking about how out of my mind I was.
I can only imagine this will never work kind of talk.
Oh, I have so many stories about people who were actually even in the modular business telling me I was crazy, and maybe I am, but it's so nice to see the industry growing at the rate it is. And I just heard that the world of modular is expecting 1,200 people this year. People from 20 countries. It's a part of the industry that is not stopping right now. And I think that the level of improvement and innovation that's coming our way in short stead is exciting and worth noting. And the good news is that I don't know a developer who has any major pipeline that isn't asking someone either in their world or in their company to invest in understanding the opportunity.
Yeah, yeah, I can imagine. They not just through a diversification like program, right? Like I'm sure that they want to, and like you said, the more you do it, the better you get at it, the more comfortable you get, the less risk there is because you're building tools, you're building knowledge, you're building all these things along the way that only help over time. So yeah, I can imagine that's only going to be continuing to grow.
Yeah, I mean, talking about technology, imagine you get a floor plate that works modularly, that's a series of 3 mods that varies whether it's 1, 2s, or 3s. You get that all laid out, and then you write a Dynamo script to create the rest of the building. Pretty darn efficient. So.
Let's talk about that tech stack that you guys have developed. You're talking about something that's now, you said, been in development since 2008. I'm sure a lot's changed, but give us an idea of the kind of the tech stack that exists. And I don't just mean software. I guess I'm interested in all of it. I'm interested in, as much as you're willing to share, like what is the process? What are the tools? What are the things that, let's even narrow it down a little bit. What's possible now that wasn't possible 5 years ago? And how do you at FullStack achieve that?
Yeah, I think it's amazing because I talk about how exciting the technology blend with design and manufacturing is. But the interesting and most important thing is what I've been talking about a lot, which is the thought leadership and parametric process by which we create buildings as a group of developers, engineers, architects, contractors. And the collaboration tools associated with that also require the willingness on the part of the participants. So, for instance, and I'm not ignoring your question, I'm just sort of building it up. So one of the things that has to happen in the design for manufacture process so that you can utilize the tools, some of which I already mentioned, is that you need an architect and engineers for that matter to be willing to share agency with the system that we're going to use to create the building. So FullStack Modular has a system. It has a structural system. It has an MEP distribution system. It has a waterproofing system. It has a self-sealing facade system. And it has an erection system in process. And all of those are part of what we have. So now all of those pieces and parts have both physicality and technology associated with it. Now what we need to do is we need to, with an architect, we need to share those pieces as sort of a portion of the agency and tools with which the architect can use to create the building. So that transfer is 2-dimensional information, but it's also 3-dimensional distribution and understanding of how the things go together on the site. And all of those things are part not only of our system, but also part of our process. So it is not anymore getting a completely designed building that doesn't pencil out conventionally, saying, can you modularize this and make it cheaper? Please wave your magic wand. The people in the industry are understanding that it is something you have to be willing to share. If the architect or designer or developer is willing to incorporate these systems and processes into the design for manufacture process, it goes a lot faster and cost predictably.
I'd like to get back to the tech and the tooling part of it because I think the audience would be interested in hearing what those pieces are. Are robotics involved? Obviously, CNC's involved, and it goes, I'm sure, way beyond that. But the idea of, I've done some of the panelized construction, not modular, not volumetric modular. And one of the things that was very clear was that it wasn't cheaper, but it was faster. And that only became clear to us over time. That wasn't even said up front. Obviously, speed is an issue in construction projects. The projects that I was working on happen to be education facilities, which have a deadline that is about kids getting into a classroom at a certain date. And so working from there backwards, it kind of boxed us into using a system like this because the speed was so much greater. But it didn't cost any less. Is that still true? Is that because I think, can you modularize this and make it cheaper is kind of an uneducated question to ask because it's like there's 3 constraints, pick 2, right? It's fast, cheap, and good. Is that still holding true with the solutions that you're offering from FullStack?
think I mentioned a little bit earlier is like, what does a building cost? Just because you bought it at $100, did it really cost $100 at the end of the day? Chances are no. But on top of that, I did explain that the repetitiveness and utilization of the system and the ability of the labor, whether that be robotic labor or human labor or some combination, the repetitiveness of it increases speed, decreases cost. So the more that gets embraced, the more chance you have of decreasing the actual cost. You're definitely going to also decrease the time, and they are linked to each other. So with a repetitive process, you definitely have the opportunity to save, I would say, up to 20, somewhere between 15 and 20% against a conventional solution of the same type. So that is definitely possible, and it requires incorporation of those system and processes in a way that is incorporating, diminishing the amount of variability, circulating around a corridor with units rather than mirroring them, using a minimum amount of variety of, say, modules, maximum of 6 instead of 27, because all of those things increase productivity and the capacity to automate it in a rapid shifting form. So whether that's machine code or instructions for a carpenter to build or anything else.
So if we get back to the idea of like what in your world is now possible that wasn't possible 5 years ago, and learning everything that you've learned, is there anything you can share in there that is an interesting process or tooling or system that is really changing the game for you guys in the last 5 years?
Yeah, I think one of the things that I mentioned earlier, which is that if you can come up with a floor, even a two-dimensional floor layout that works using our parameters, you can write a Dynamo script to do all the drawings. I mean, in a modular building, the production drawings are, for a 100,000 foot building, thousands and thousands of pages. It can actually be created in a couple of hours by running some scripts that really didn't exist in 2007, 2008. The other thing, obviously, that's happened because of the evolution of the industry as a whole is we didn't really have access to libraries that had accurate dimensions in them. In 2007, 2008, occasionally you would find one, but there is nobody in the industry right now that doesn't have, I shouldn't say there's nobody, there's almost nobody I've found that doesn't have an accurate CAD library that you can access to make sure you use those pieces correctly and they're dimensionally accurate. And for us, with precision of less than an eighth of an inch across all systems, that's a huge deal. So that's a big advantage. And of course, the transferability, because so many companies, AutoCAD, CATIA, they've all been focused on integration for manufacturing. The cross-code, cross-data, common access to information is so much more available than it was. So much in 2007, 2008 was hard-coded. So every time you change something, it didn't work. And so much of that exists today is relying on transportable data sets. And so that's a big advantage.
I can imagine. Can you give us an idea about the FullStack Modular itself, the company, like what kinds of divisions is a weird word to use in a company where you're talking about full integration, but how is your company set up to operate in this really collaborative way where everybody is on the same side of the table?
We are definitively always a design manufacture solution in what we call the sort of design manufacture construct world, which is design, build, insert, industrialized construction. So we are always that. And we are often collaboratively working with a general contractor to provide a full design manufacture construct turnkey solution. But there is really no way in our world to do our job unless we are not sitting at the table day one with the design, manufacture, construct team and driving everything that goes through the point that the mods are wrapped and ready to go to site. That's what FullStack does.
Okay. I remembered what I was going to ask you earlier, and it has to do with that last piece that you just mentioned about getting it to the site. And I've heard from other either modularized construction, actually I heard it directly from a volumetric modular guy, was it starts with logistics. The design problems, like can we get the things to the site, on the site, placed on the site? And if we can't, basically you start there and work backwards. because if you can't, it's not an option. So is that still hold true?
It's funny. It's people say that to me all the time. And I'm not saying there's not a place where you can't put a big mod, because of course there is. But I've been in New York for most of my career, so I can pretty much get a mod anywhere. I actually would say, and by the way, I'm not dismissing that. Obviously, moving something that's 12 to 14 feet wide and 30 to 40 feet long that weighs 15 to 17 tons is nothing. It's something you have to think about. But to me, the biggest concern, and we talked about it earlier, is like, what gives value to the end user, whether that be the developer themselves or the people who are going to live in it? What gives value to them? And how do you make sure that you're preserving some of that value for them? And one of the big frontiers in industrialized construction right now is, how do you make sure that the work that's going on doesn't absorb all of the savings that industrialized construction creates? And that interface is key. And we have FullStack been spending a lot of time on that. At this point, collaboratively, we're not doing it ourselves, but we are spending a significant amount of time creating technologies, whether they be augmented reality or effective graphic 3D communication, on how things go together on site so that they can get the people that need to put it together the right information, so they're not overcharging for the work that happens there. That's a big frontier in our industry right now.
Yeah, so the idea of 4D sequencing ahead of time, that's a big piece of the puzzle, right? Because basically then you're providing the instructions to the installer to do it. Like, you've thought through all of those logistics up front.
Yeah, not only have we done that, but I currently have an on-site electrical design for small, medium, and large buildings. I can quantify how many connection points that are going to happen so that they can look at the trades that will need to make those connections. They're going to get all the pieces and parts that we manufacture in the factory in order to connect them. Because we are an all modular solution, the full SMEP is done in the factory and just needs to be connected, and we can show them drawings and 4D sequences of how that happens. We're not sending them out with glasses right now, but we can certainly provide them, an iPad that shows, oh yeah, this is how you do this connection. Now, if you can take all that and say, okay, Mr. On-site plumber, you're doing 168 of connections that look exactly like this, it's much easier. And we're taking all the risk out of it. If we make at FullStack, if we make a mistake based on the design and dimensionality, we take responsibility for it. But assuming you're getting everything you need, what do you need to do? To me, that's the place where there's opportunity and savings to be gated for the end user, whether that be an owner or a developer.
Yeah. It's so interesting to see this shift over decades, I guess, of, remember when a set of plans was 12 sheets and the contractor was responsible for figuring out how to run the ducts. And like, we had a lot of single line diagrams back then, right? Yep. For HVAC, for electrical, for plumbing, all those things. And now that is flipped, right? The script is flipped there. And all of that's figured out up front, which makes the modeling process a lot more complicated, complex, right? There's a lot of complexity there. How do you feel about all that? I mean, obviously, there's huge efficiencies to be gained there to spend the time up front and not worry about that stuff not working when it's time for construction. So I'm sure you feel positively about it, but it's also a huge shift in the industry to put all of that onus on the designers up front.
Yep, it is. But look, it wasn't always that way. If you step back 20 years before when you're talking, like, it was all like that. Everything was completely designed. It wasn't necessarily in 3D CAD because there wasn't 3D CAD. Everything was absolute at that time. The engineer knew exactly what they wanted, and they knew there had to be some coordination from clash detection because there wasn't a way to accurately. But those, if you look back through the archives 50 years ago, the drawings were 1,000 pages then. So I think actually we're just getting back to basics in my mind. And I think relying on some random person who's the lowest bidder on a project to be able to figure out what it is that the engineer had intended is a little bit delusional.
What could go wrong? Yeah.
Exactly. Well, look, you're talking to the wrong guy to give you an opinion on that, because I don't think there's really any other smart way to do it.
Yeah, interesting. So, okay, so what are you excited about in the developments, what's coming out? Like you're making a case for this type of methodology of procurement for buildings, for obviously there's a huge demand and need for housing, like what you're specializing in. And this is a great way to deliver, and it doesn't all have to be capital A architecture. Not that what you're doing isn't, but there's a huge need out there. We only need to do more of this. Make the case for why people should be at least architects and engineers who are interested in solving some of these huge problems in our society that need to be addressed for the way that you're going about it.
Yeah, I think we all in this industry want to see the things that we create manifested. And we talked about how many of them don't get.
Yeah, there's a great saying, if it doesn't get built, it doesn't count. That's in a lot of architecture.
Yeah, so I'm like, and I obviously lots of friends who are architects and engineers, like who, all the projects that never got built, who cares? And so I never would say that volumetric modular construction is the answer to everything. But in the world that we play in, it's radically efficient. And so if you want to see things get built and you don't want to spend your life in job meetings talking about like which toilet you're using, even though the project hasn't even been financed, like this is a really good way to do it. It gives you enough added parameters to give, and I love architecture, but to give architecture the ability to change the way that the building feels in the environment in which it's going to live and the way that the people who live in it interact with the space that is created for them in a highly sustainable, incredibly carbon responsive way that doesn't require you to reinvent the wheel. Yeah. And so if you're an architect who's in the multifamily hotel student housing space, like this is a tool that you ought to at least understand the value proposition. And I think you're going to like it.
Yeah, you check a lot of boxes with that, with your sales pitch right there, because I can only imagine too, and maybe you can shed a little light on this, but this is a scale question, but it's like, how many projects are you guys doing a year? It seems to me with this approach, there's more throughput as well. So you're realizing more designs getting built than a typical outfit would see.
Yeah, no, I think the percentage of throughput is bigger. I think the other thing that is worth noting and something that you just touched on is that when you're manufacturing, the throughput isn't necessarily what comes out of your specific geographic location where you're assembling mods, but it's what can you get through the process in a way that is time effective, quality effective, and produces what it needs to. And manufacturing has always been a make or buy conversation about everything that you do. Construction hasn't generally been that way because the decision making was so dispersed between the trade jurisdictions and the engineering jurisdictions and all of those things. So the one advantage that you have when you're manufacturing is you're just trying to figure out how to optimize what it is that you're creating and meet all the required parameters, including design, including code, including technology integration, including sustainability, including all of those things. But you have lots of flexibility in how you do it. And frankly, it doesn't really matter unless there's some regulation associated with it, where in the world that piece and part is created, because you're putting it together in a manufacturing process rather than in a construction process.
That just reminds me of the Toyota production system. Car makers in the US versus kind of the Toyota idea back in the 70s was just-in-time manufacturing versus warehouses full of parts. I'm sure you're familiar with all that. So can you go into that just for a little bit to talk about that? Because like you're saying, if parts can come from anywhere, obviously, this is still a logistics issue, like a procurement issue of all those things, because you need them all to put them all together, and it has to go in at just the right time so that the thing can ship out and get put onto the site in a complete manner, rather than, like, there were stories of the Ford production line where because nobody was allowed to stop it, pieces got left out, for instance. So how is that working with your guys? Are you guys buying all that in huge bulk numbers, or are you buying just what you need, just when you need it, and dealing with it from a as-you-go standpoint? How do you view that for your strategy?
Every time all day, our purchasing department is a make or buy conversation. So every time we're building a project, it's should we be making this in the factory? Do we have capacity and labor? Or should we be buying it so that we can get more throughput so that we can meet our schedule for the next 3 buildings coming out? And then the good news is that a lot of the suppliers who traditionally had been very construction focused, either you get 100% of everything or you get what we have in stock, are now very open to packaging, assembling, delivering kits of whatever we need whenever we need it, which makes that a lot easier. And oftentimes they'll warehouse it for us.
That's interesting. So what have we not talked about that we need to talk about here? Is there anything that we've missed that you think is worth putting out there into the audience's ears?
Yeah, it's reiterative rather than necessarily we've missed. But this process does require a significant shift in approach and attitude by all of the parties. The value proposition is significant, but the request is also significant. If you don't change the way that you develop projects collectively as a team, not only does this process, this design, manufacture, construct process not work, but in my mind, we have no hope of ever meeting the current need, which is only growing.
Right.
And I want everybody to absorb that because we have a problem and we're not solving it.
Yeah, that's a great call to action. And obviously, you're a great example of making that decision and pursuing it to the nth degree. If you have any words of advice for people taking that first step, what would that be? Because is it to talk to somebody like you? Is it to go to the conference that you talked about earlier on? Like, where do people begin this process? Because if it truly is about meeting the needs that are out there, then these companies like FullStack Modular need to be willing to share. I assume that's happening in certain capacities. So where does somebody begin?
I would pick a project that you want to develop and commit to following this process, at least from an initial engineered schematic design to see how it works. If you have the opportunity and your friend is doing it, then by all means sit in on their process. But I would give it a shot because the chances of you being severely disappointed are slim. The possibility of you not recognizing all the savings that you had hoped is significant, depending on how seasoned the team is. But I do suggest that you visit some projects. And there are projects all over the world right now that are fun to look at. Some of them are the tallest modular buildings in the world. Some are the largest installations. Some of them are super automated factories. There's a lot going on. And so I would dig in and take a little bit of a risk because there are so many competent industrialized construction opportunities in the United States and in the world today, and it's growing daily.
One last question here, because this has crossed my mind a few times now, is how regional are you?
We have a factory in Portland, Oregon, and we have a factory in New York. And generally, it's around 500 miles, but we are building some stuff for export right now, both to the Caribbean and out even farther. And some of our projects in Portland, because we're right on the water, are significantly longer, 900 miles or stuff. So from San Diego to Seattle. So there are opportunities, but we can't really do anything anywhere. There are transportation limitations from a cost perspective. So 500 miles is 1,000 max, I think, much more than that. And you're significantly decreasing the value proposition by the cost of transportation.
I bring that up because you talk about going into this type of delivery and procedure workflow, like there's room for more, right? There are a few companies out there like yours who have been in this for a long time and who have a lot of experience and knowledge and wisdom about it, which is super important. But at the same time, there is room for a lot more players in this market, because the geography, like you're talking about, the logistics, the shipping, like all of those things, we need this kind of thing all over the place to be able to meet the demand that exists.
Yeah, that is our view. And if you fast forward 5 years from now, our goal from FullStack Modular's perspective is to have a front end franchisable solution so that people can run their own factories wherever they want in the world or in the United States, et cetera. That's where we'd like to head because of what you just said, that it's generally relatively local and the needs all over the world are significant.
Mm-hmm. Well, Roger, this has been a fantastic conversation. There's so many things packed into this episode that I'm going to do my best to pull out the salient bits and put them into the show notes. And of course, we'll link to FullStack Modular and you online. Is there anything else that you would ask of the audience or that you would want to point them to finish up here?
I would encourage you to watch what's going on in the industry, put ticklers for podcasts and presentations and news that's coming out, which is literally on an hourly basis on things going on in industrialized construction and modular industry, because it's both fast moving and significantly improving as we speak and live on a daily basis.
Fantastic. Well, Roger, once again, thank you for this conversation. And I'll include all of the links to the appropriate things in the show notes for this episode, where you can also follow along with what Roger's doing. So thanks, Roger.
Thank you, Evan. Appreciate it.